This video shows how to specify and manipulate basic JWST imaging mosaics in APT. Other modes, such as IFUs or fixed slits, may also use the Mosaic functionality, but the operation is similar to that shown here. We start with an APT file already loaded with one target, the Galaxy M51, and two simple observations, imaging observations, one with MIRI and one with NearCam. We've also already loaded the DSS image of the target into the Aladin display. We can ignore all these yellow caution signs that are just indicating that we have not run the Visit Planner yet on our proposal. That comes much later. We will now look at the MIRI and NearCam cases separately. First of all, let's open up the MIRI imaging observation, and we can see it's a simple one filter observation with two dither points, and that single MIRI field of view is shown in the Aladin display. If we want to mosaic let's say the inner part of the galaxy here, we can go to the Mosaic Properties tab and we can estimate how many rows and columns we might need. Let's assume 4 and 5, and we can see there that that covers the inner part of the galaxy fairly well. A mosaic is defined by just a central coordinate position for the target and the grid that we define in the Mosaic Properties tab. By default, the grid is shown at a V3 position angle. That's an observatory reference angle of 0 degrees. That may or may not be the angle that your actual observation will occur at, because it depends on where your target is in the sky and the time of year that the observation is made. For an observation like this, where the object is fairly symmetrical and the field of view is fairly symmetrical, we really don't need to constrain the position angle very much, but we might be interested in knowing exactly what kind of coverage we might get with the mosaic. One way to check that is to go to the View in Aladin button and click the Coverage Circles button. And that just gives you some reference circles that show, depending on the time of year, exactly what you might expect to see in your observation. As long as the region of interest is basically centered in the field of view and is visible at all times, there's no reason to constrain the position angle, which only constrains the schedulability of the observation. Okay, well, let's go back now to turn off the coverage circles, and we'll go back to the form editor so we can see that in the mosaic display we have all 20 tiles listed down below here. All the tiles are included, as you see in this middle column. Over here it shows the observation number, observation number 1, and the visit number as the second number here. And you can see that there are 20 tiles, there are 20 visits. Each tile is in its own visit. One of the things that we might need to do in certain situations would be to adjust the positioning of the overlap or of the row and column shifts, and so now I'll demonstrate that for you. One way to change the overlap is to simply slide the slider bar, as I did there, or you can actually come into one of the adjacent boxes and actually just change to a value manually, and you can see again there that the display adjusted after the fact. Interestingly enough, one of the things that you can do with row and column overlap is actually go to negative values of the overlap, and that actually spreads the tiles out where they're not actually overlapping. If you had a reason to do that, you could do that, but you see it leaves gaps in the grid. This is still considered a mosaic, though, even though the tiles are not overlapping. Okay, let's go back basically to 0. Okay, the other thing you could do is to adjust the row or column shifts. And here I'll take the row shift and slide it in one direction and release, and you can see that what happens there. Or you can go back in the other direction, obviously. Take that back close to 0. And now we could do the column shift. You could do the same sort of a thing, where the columns shift one way or the other as well. Now, if you actually did a mosaic like this that was no longer symmetrical for rotation, you would probably need to constrain the position angle, at least to a fairly narrow range, to make sure that you were getting exactly what you wanted out of the observation. Okay, well, let's now go to the NearCam observation and see what the situation is there. In this case, what we'll want to do is define a mosaic that covers the region of interest and not worry too much about the fact that there are gaps in the mosaic. We'll fill those in by adjusting the dithering on the observation. The near cam field of view, you can see, is actually two adjacent fields of view, and the target position is actually in between those two fields of view in the gap. So let's define a mosaic now that's just two fields of view by 1. And there you can see that we pretty much cover the inner part of the galaxy. And now let's go to the near cam imaging specification, and we can adjust the dithers. You can see here right now we have no dithers specified. You can choose any of these you want to. I'm going to just, for example, choose the full dither pattern, and then for the primary dither I'll choose the 3 tight pattern. And now you can see in the display over here that the coverage is filled in. Obviously, you can use the Aladin display to investigate other dither patterns as well if you wish to. There's an article in JDox, the near cam primary dithers article, that shows all the details and shows the overlap of the fields better, the uniformity of coverage, and that sort of thing. Okay, well, if we define this as our mosaic, we actually might want to specify an angle for this mosaic now to align the long dimension of the coverage with the main part of the galaxy. If I point at the corner of the mosaic, you can see I have the rotation icon, and if I click and drag, I can bring this around, let's say, to about 300 degrees. You can see the angle at the bottom of the display there. Okay, when I release, the rest of the grid snaps into position. It's best, though, to not give a specific value for the position angle if you don't have to. It's nice to leave some scheduling flexibility. So, for instance, if I grab this and let's say go 15 degrees in one direction, I'm still covering the inner part of the galaxy pretty well. That's good. If I grab it again now and rotate it to, let's say, 285, that's 15 degrees in the other direction. Again, I'm covering the galaxy pretty well. That's 30 degrees of scheduling flexibility. That's pretty good. So why don't we specify that now in the near cam observation? We come back to the observation template, select special requirements, and we will add a position angle range special requirement. I was just looking at V3 PA, so we'll click this box to set to V3, and now I can enter my 285 and 315. Okay, and the grid is shown at the midpoint of the range that I specified. The next thing you would want to do would be to use the Visit Planner to check on the schedulability of your defined mosaic. I won't do that here. There's a separate video that goes over the Visit Planner activities, and you can refer to that. This completes the demonstration of the basic functionality for mosaics. The remainder of this video covers special cases that may arise in certain situations. Okay, now I'd like to demonstrate some of the special functionality for mosaics. Let's say you wanted to remove a tile from a mosaic. For our Miri mosaic we have defined here, you can see that the tile at upper right really doesn't have much in it. That's going to take real observing time to cover that tile. If it's not anything we care about, we might want to get rid of it. So let's go to the Miri imaging observation, and I'm going to open it up to the individual visit level, and you can actually see here that you can select individual visits and see where they lie in your grid. And it turns out that visit number 1 up here is the one that we want to remove. So let's go to the full observation again, and now we will look at tile number 1. And you can see if I click on tile number 1 to select it, that one of the options is to remove the tile. So let's do that, and you can see that the tile has disappeared. To add a tile, the PA of the mosaic must be fixed, and I've already done that. For instance, if we go and look at the special requirements, you can see I've actually fixed the angle already. And let's say we wanted to cover this companion galaxy with another tile up here. So to do that, we come into the Mosaic Properties tab, and we can say Insert New Observation into Mosaic. And if I click that, a couple of things happen. First of all, there's a new target added for the new tile that we've just added as a separate observation. And there's now a Miri Mosaic group folder that includes the original mosaic and the new observation that we just made for the new tile. By default, this tile is placed at the center of the mosaic position, which is not where we want it, obviously. So we'll come into Aladin and grab the tile and move it to where we want it, onto the companion galaxy, and release. Now if we go to the View in Aladin screen over here, we see that there is a pending change. That changes the coordinate move that we just made to reposition the tile. To commit that back into the proposal, we can say commit all, and that is now going to be visible as the new coordinate on your target at this position. Going back to the Mosaic group now, if we look at the entire Mosaic group in Aladin, you can see the original Mosaic plus the tile that we just added. Now, another thing that we might need to do in certain situations would be to split a tile to a new observation. Why might we have to do that? Well, after running the Visit Planner, you may encounter a situation where the mosaic is declared unschedulable. This usually happens on a larger mosaic and usually indicates that there are one or more tiles that do not have guide stars at the same time as the rest of the tiles. So the entire mosaic cannot be scheduled. After diagnosing the situation in the Visit Planner, and again there's a separate video for the Visit Planner, one way to proceed would then be to split the problem tile or tiles out to a separate observation for scheduling those tiles at a different position angle when guide stars are available. So let's say that tile number 11 was the problem that didn't have guide stars. We select that tile and we can say split tile to new observation. We can now see that there is a separate target for the new tile that we just split out, and there's a separate observation for that tile specified in the Mosaic group. It's important for these observations to be in the same group because they will be processed together by the data management system and considered as part of the Mosaic, even though they're separate observations. If there was another tile that had the problem, obviously you could split that one off as well. The final thing that we might need to do at one time or another would be to copy a tile to a new observation. This is a situation that would only be encountered if the actual observation of a tile failed and needed to be rescheduled to complete your mosaic, in which case your program coordinator will direct you to make a new entry for the reobservation attempt. It works exactly like the other functionality that we saw. Let's pretend that tile number 5 was the one that was missed. We can say copy tile to new observation. And again, same thing happens. We get a new target position for that tile, and we get a new observation of that tile that we can then go into the observation specification and change the angle and find the time when that tile actually had its guide stars. Note the appropriate labeling that is used to keep all this straight in the Mosaic group. In this video, we have demonstrated the basics of using the Mosaic functionality in APT. The JDox system contains additional information, including an APT Mosaic Example article that uses a demonstration proposal you can access directly from within APT. Go to the File menu, click and come down to Demonstration Proposals and over to the Mosaic Example. And if I released here, it would load up this example program that you can go through with the JDox article of interest to work through some examples. This concludes this tutorial on mosaicing with APT. I hope this was helpful to you.